We have a nice panel here today. Sort of going across, we have Brandon. Actually, do you guys want to introduce yourselves? It's probably better than me trying to introduce you.
Much more
yeah. Oh, yeah, well, there is that. I didn't practice that all morning. So let's go ahead and introduce you guys as well.
Sure. So I'm Brandon Phillips. I'm the CTO and co-founder of CoreOS. We build a lot of open source software in the space and then have a couple of enterprise products, Tectonic and Quay.
Christopher Lilienstolpe, CTO and co-founder of Tigera, home for Project Calico and various other networking projects and policy projects in this space.
So I'm Frederick Kautz from Red Hat. I'm from the Office of Technology, and I focus on container networking, trying to work out where we should try to move forward as an industry.
Well, Ajay Siva, I'm currently independent. I led the Contiv Cisco-sponsored open source project. Before that, I was in virtual networking, SDN, et cetera, et cetera.
All right, great. So, look, one of the biggest things, the title of this talk was sort of the history of pulling together a spec and then still being able to differentiate enough, well, something along those lines, to be able to compete in the space, basically making network a competitive technology as well as a core technology. One of the things that I saw, having been through a number of open source projects that pulled lots of underlying resources together, was that the networking specification was often a problem. It created a lot of sort of disconnect between different vendors. And one of the things that's come out, I think, out of the Kubernetes space specifically is a networking spec that is not like that. It's not broken at its base, as some have said, and instead is a good baseline. At the same time, we want to look at how we differentiate that. And I'd love your opinion on how you got to the point of a stable specification to begin with. And then we can dive into more interesting topics.
So since I have the mic, I'll go ahead and start. So early on, one of the things that we did in the networking SIG is we were very careful on how much we scoped. So I think you have to start off with small. These are very complex topics, and there's a lot of edge cases that can get you. So we decided to start off with, well, let's talk only about ingress traffic to start off with, and let's get that right, and slowly add it on top of that. So I think part of it is just really good scoping and getting everyone on board to the same concept, and then we discussed several different approaches to deal with it. And I think that easy. I can't say it's easy, but rather that smaller scope, I think, led a long way towards getting the model right.
So, I think the other thing is that we really focused on having this be actually user requirement driven rather than vendor driven, which is some of the things that have bedeviled other projects like OpenStack in this space. What do people want to do? People want to have their containers be able to talk to one another. People want to be able to get traffic into their container infrastructure. The spec should allow the end user or the operations team to identify what behavior they want. It shouldn't be in terms of a networking primitive. It should be, I want things like A to talk to things like B, or I want this kind of ingress traffic, and leave the rendering of that outside of the scope. That's up to an implementation provider, rather than coming in with we're going to model this as an L2 segment-based model or a whatever kind of model, which immediately breaks what other people might want to do to render that. So you've got to stay focused on what end users are trying to accomplish rather than what vendors would like to have you buy. The minute you let that into the spec, I think things go horribly, horribly wrong.
Yeah, and I want to take it back just a little bit. I think one of the reasons that Kubernetes has been able to pretty reasonably, insanely move forward in networking is early on, the core team at Kubernetes said it's going to be L3 networking, where every single pod is going to get an IP. All the services are going to get a unique IP. It's going to work with plain DNS. We're able to use normal forwarding and routing. And I think that fundamentally changed the conversation. It moved us from the kind of very L2-centric world of IaaS up the stack. It was a bold move. It was a bold move, unlike removing headphone jacks, in that it was right on the cusp of whether the industry was ready for that change. For the longest time, it's always been like one server gets one IP, and we're moving finally to this model where with Kubernetes and with the concept of pods and the underlying networking, where you have to have something a little bit more advanced as baseline, not as like some SDN initiative inside of the company, but baseline infrastructure. And so I think that was a pretty bold, cuspy move that the team made early on in Kubernetes. That's enabled a lot of what we see in the networking space today on it.
Yeah, all right. Balaji, did you have any? No? Yeah, okay. Great, so that's the history. So we've gotten to a stable baseline. Now the next question is, there are, some of you are from vendors that have networking technology, some of you looked at networking technology as a core way of differentiating your products. Can you describe maybe some of the ways that, even though the spec itself, like you said, is very abstract in its modeling, still gives you the flexibility without breaking people's ability to potentially migrate applications between different environments because of sort of a consistency from that view? Is there something specific that really enables the ability to still compete, provide interesting differentiation across the underlying platforms?
Yeah, so I guess, okay, got it. So is this better? Can you hear us? So before we get further along in the conversation, can I just get a show of hands who's used network policies inside of Kubernetes? Okay, so we have about half the audience that's used network policies. So just want to set some baseline here. So inside of Kubernetes, there's the concept of labels. Labels get applied to essentially every object in the system. So you have the idea of, I have this running process. This running process is a pod. That pod has a unique IP. And on top of that unique IP in that pod, I set labels like app equals nginx and environment equals prod, et cetera. And so this fundamental concept, ubiquitous to the entire API, is this label idea. And so the networking policy, kind of the abstract spec that we've been talking about, this networking policy allows you to take these things that, in order to even use Kubernetes, application developers must use. They must use labels in order to deploy things inside of Kubernetes correctly. And so you have all this rich, wonderful metadata in order to build systems upon. And so the network policy allows you to start to enforce ingress, egress, traffic control rules, that sort of stuff on top of that base metadata. Just want to set that baseline so we all know what we're talking about.
All right.
And as a non-networking vendor, I'll hand it off to somebody else to talk about the.
So I think, again, this becomes an interesting thing. I don't think you necessarily want to bake lots of hooks directly into the base API. Again, this leads to OpenStack problems. This leads to a whole bunch of discontinuities in the infrastructure, and you now get vendors arguing over this hook versus that hook. What you need to have in that spec is a way for someone to express the intent of what they want out of their network, out of the way they want their pods to communicate. Once you have that intent, I might render it very differently from someone else. Tigera might render it very differently from someone else, and the way I render it might be unique to the way other people render it. But as long as everyone adheres to, at the end of the day, having the same end result, A can talk to B, but C can't talk to D, or whatever it is, it allows you to migrate. The minute I start baking proprietary hooks into the APIs, it's at that point we might as well call it done and walk away, because we'll never get to convergence after that. So a hook, so a vendor-specific extension, for example. Maybe I'm a vendor of a DPI platform, so I want a hook that says, there's a specific API call in CNI that I want this, this container to be sent off to my DPI appliance somewhere else in the infrastructure. So now all of a sudden we have to have the concept of tunnels and everything else within the underlying network layer in order for that hook to work. That's too specific a case. If you want to render that, you could say containers labeled A, should be able to talk to only to containers labeled X. If those containers happen to be DPI boxes, then great. That now I've allowed somebody to use my wonderful DPI containers, but I haven't burdened the API with something specific just to me. And then someone else is going to want to have a hook that does almost exactly the same thing in a different way. Again, witness Neutron. I'm sorry, I'm picking on Neutron, but it's such an easy topic.
So approaching this from the other side, you look at OpenShift, and part of having that really well-defined API is incredibly important for us, because if you get that API, it's easy for us. We just stand it up, install the SDN, and tell them how to communicate with each other through CNI and so on, and then things ideally just work. And it means that having that clear specification that just works uniformly across all means that we can bring in whatever SDN is necessary to get the job done. And our customers may also have their own SDNs who they may have a lot invested in a particular vendor, and to tell them, hey, you should get rid of all of your SDN stuff and use this other thing instead because we only support that, would not come across very well. So by providing that API, it makes it easy for customers to leverage their current SDNs, but give them most or all of the benefits that Kubernetes would provide for them. So I think that's key to the success is those very clean APIs.
I think the one thing I guess I want to say first of all is that the batteries included with replaceable models is really, really nice in the overall container ecosystem, maybe in other ecosystems as well. But this is sort of really refreshing, compared to like where I came from, where I was trying to create a virtual switch for VMware, Hyper-V, and KVM, and you have all these vendor lock-ins that you have to fight for. So this spec allows you to actually innovate on top of that. When we looked at Conti back in last year, we created pure IP connectivity, overlay networking, because in some cases people want overlays. So it allows you the flexibility to vendors to create differentiation and add value to it. So in a way, I think vendors can differentiate, and I think the spec is at the right level.
Okay. So actually, I wanted to. Oh, yeah.
Brandon wants to
revise.
So we're talking about two different things. I just want to make sure the audience understands. Who here knows what CNI is when we say CNI? Okay, good. Okay.
This is the right audience.
Okay, making sure.
Okay, so actually one of the things that you guys mentioned, you talked about labels and how important labels are to the overall environment. I actually wonder, when you're talking about rendering things and the fact that the underlying infrastructure gets rendered sort of as the underlying infrastructure needs to be, one of the topics that I think comes out of that question is using labels to provide segregation, provide a layer of security. Is that adequate? Is there something more that's needed there? Or can you define enough of the policy model through labels so that you have consistent security potentially across multiple deployments of a Kubernetes environment? I don't know if I described that in the way that you were thinking, Chris, but that was kind of
Sure, we'll take a stab at it. I think the answer is yes, and probably it's one of the only ways you're going to be able to do that. So if we think back to the way we used to build virtualized network environments, and you'd say, okay, I'm going to take this application, I'm going to put it in VLAN 1. I'm going to take this application, put it in VLAN 2. So everything in VLAN 1 can talk to everything in VLAN 1, everything in VLAN 2 can talk to everything in VLAN 2. That's already a problem. Go ask the guys at Sony about having ubiquitous connectivity within a realm. It ends badly, usually. But two, now I need, as we start getting this cloud native environment, I need to have things in one talk to things in two, but they're not all the things in one need to talk to all the things in two. And so that requires firewalls. So you also get this very complex environment that's also fairly static and hard to configure. If instead I start sticking labels on things, and these labels say this is X, and X should be able to talk to Y. It doesn't really matter where the X's and Y's are in the infrastructure. It doesn't matter if I have one of them or a million of them, or there's 5 of them 1 second and 40 of them the next second. the policy is still rendered on it. If I tried to do this via VLANs or VXLANs, or I tried to do this by configuring firewalls to do this, you're not going to be able to do that. You know, the policy is tied to the endpoint, what that endpoint is expressing. It's an LDAP server. It's a web front end. And then you attach your policy to that. That's the way you can actually get repeatable policy enforcement. Doing it any other way, I think, is going to be interesting.
So I can't think of any reason why we would need a different model from labels. I think that should be sufficient. But that being said, something that we have to be careful is, we're talking about the hooks earlier. We have to make sure that we don't end up with the same problem where your label, if you have a label you can stick arbitrary data in, then that becomes your vendor side channel hook that allows you to do things beyond what the API gives you. So so we have to be a bit careful with implementation from that perspective. But I think the label one, it's you see similar approaches used in other distributed systems, even things like Hadoop and so on. Like, you'll see a job with a specific set of key value pairs, which are effectively labels, and we know that model works very well.
Sure. So I think the root of that question is really around two things. Ensuring that the system, whatever security system you put in place for your networking, always fails closed. So that means that, like, by default, things in your network or things in your cluster without labels, or things that don't comply with policy are not able to route. And then also, Kubernetes over the last 2 releases has gotten pretty rich role-based access control. So you do have confidence that, you know, only users who authenticated with LDAP and are in the correct groups to have access to the namespace are able to create pods that eventually end up with the right labels. I think there's a lot of really powerful abstractions that have been introduced to, like, protect those labels and ensure that people who intended to have access to that network are the people who actually end up having access to the network.
Well, that actually negated my next question. So,
sorry.
Well, I was going to ask, you know, how does roles-based access and labels and the sort of almost the beginnings of multi-tenancy that gets derived from that start to come together? I've talked to a couple of companies that are trying to understand how to better deal with multi-tenancy within the current Kubernetes environment. I know there's a lot of work going on in that space. Do you guys have any comments on how the network policy, roles-based access, how those pieces and namespaces, et cetera, start to fit together to enable a better, more segregated world for those that need that? Yeah,
so this SIG auth that we're a member of, Eric Chang, he may be in the room, and a bunch of the Red Hat folks, and essentially the entire Kubernetes community, has focused on creating a really, really powerful role-based access control system. And I would say that the only risk with the system that we've created is it's so powerful as to be difficult for humans to actually be able to parse and understand. And so I think we've done a good job of creating the abstractions. Essentially every single resource, whether that be a network policy resource or a pod or a namespace, is able to have policy applied to it. And I think what will fall out of it, similar to what we've seen with labels inside of Kubernetes, is we now need to learn the patterns that make sense for that really powerful framework that we've had. It's similar to Unix extended attributes and ACLs. Like, we've created a really powerful system. Now, what are the patterns that are going to actually be useful? I would guess that a lot of it comes down to namespaces mapped to small groups, like, you know, single pizza size groups, and that is that'll be the foundation that a lot of the businesses start from. Is this namespace I trust, this namespace has this network policy, these are the people that are in that namespace, and if something goes wrong, I know who to page.
So talking about security, and I'm a change the focus slightly. So if you look at something like, from a security and labels perspective, and then you look at something like SE Linux, SE Linux is labels and an action based upon what those labels are. So this is a well understood model. There is complexity that arises, as was mentioned, but in the whole, it should provide a really good base to build out effective security. So.
I think another, I guess, your question was like role-based access for the overall. Can I create a cluster? Can I create an application versus a network-specific policy? I think network policy should be handling the network-specific part of it. Role-based access control should be accessing, like, should I, deploy the application? So I think these are two different things you can look at, right?
I mean, we already have some folks, in this space, even in advance of RBAC. And so, I've seen people that have done things like in their CI/CD chain, validate if the person doing the check-in is allowed to assert that label in the pod spec. And if they're not, the CI fails, or so there's many ways of solving this. Obviously, it's best if it's solved within Kubernetes, but there are people who have been already tackling this. The interesting thing about using labels, you can use namespaces, and namespaces are one way of segregating things, but you might end up, how do you represent potentially multiple hierarchies of things, right? So namespaces are a useful tool, but how do you do like subgroups within groups within tenants? So the minute you start thinking about I hate the term multi-tenancy actually, because there is not, how do you split tenants up? So it's more of is this thing in a group, and what are the characteristics of this group? There might be subgroups, or there might be a Venn diagram that's complete or incomplete. And those are the labels you attach. And then who is allowed to attach those labels is once you can control that via RBAC or via other mechanisms, you have a really rich security mechanism that doesn't impose a philosophy of how you should organize your organization or your service. It can become much more, I don't make you organize your organization the way I thought about it. You can organize the organization the way it makes sense for you.
Yeah, that's very good. So switching gears just a little bit, one of the other sort of topics in the network space, of course, is that underlying resource, the actual networking technology or non-technology in some cases that some might deploy under a Kubernetes environment. What do you guys think about the need for or the desire to have a software-defined network sitting underneath Kubernetes, and is that even really necessary?
I'm going to let Dennis go first.
Hey, I gave you guys all these questions in advance, so,
So, one of the first groups that we generally interact with when you go to a customer is NetOps. And I think one of the beauties of the Kubernetes ecosystem and all the networking technologies and vendors that have been involved so far is that really we have a full spectrum, and this is a huge advantage for Kubernetes. It means that we can go in, so one of the first things we did was CoreOS when Kubernetes was really young. We said this networking policy, this L3 everything network policy is going to be a challenge for a lot of people. So we built this thing called Flannel, and we still see a ton of usage of this where we actually are tunneling like via VXLAN between machines with single IPs to create this pod network. And this is super important. Like very few individuals want to talk to NetOps just to get like Kubernetes running inside their data center. It just slows down the project and it slows down. So it's important to have this spectrum. I don't think it's necessary. Most people don't go into production by like having a Kubernetes specific like VXLAN thing. Some do, but having that flexibility means that Kubernetes is able to land inside of an environment, prove out the model a little bit, and then build confidence that everything, we can sort out networking, we know how to route packets. Like, it's a great challenge to put to the networking team inside of an enterprise. So I have this L3 network, do you think you can route it? Like, it's a good challenge. And so I think it's important just for an adoption and that confidence building that every organization goes through in these sorts of changes.
Yeah, so Brandon sort of hit it. Kubernetes, these are IP addresses. These are IP endpoints. So pretty much anything that can get IP from A to B, be it an overlay, be it a native routed infrastructure, is going to work. And the nice thing about that is we know how to do that at scale. We've been doing it for a real long time. It's called the public internet. So we know that there's a really large proof case that IP networks generally work. So if I want to put them over a overlay network, some kind of NCAP network, that works. If I want to run it natively, that works too. And in fact, I may use different techniques depending on where I deploy. I might use an overlay in, say, Azure, and I might run native network in my private cloud. Kubernetes doesn't care. So I don't think an SDN is, and I hate the term SDN as well, I don't think, Kubernetes is a software-defined network in and of itself. You're controlling the network's behaviors by API calls. It's not an overlay network. You can run it over an overlay network or not. I think the interesting challenge for someone is if they decide they're going to deploy Kubernetes with an overlay network and they're running it on top of VMs that are on top of another overlay network. So now you have the problem of 1,400 bytes of payload and of header and 100 bytes of payload. Right? So you now get to troubleshoot the Kubernetes overlay on top of the VM overlay on top of the underlying network, and good luck trying to figure out why your network isn't coming up. But you can do that if you want, but it's not required. This is just IP traffic. However you want to get the IP packets from A to B is fine. It does not require an SDN underneath.
So they've mentioned most of the stuff I was going to say, but the one thing about Kubernetes networking model is that it's the basic requirements to get Kubernetes up and running is very small. So the things like a pod should be able to communicate with another pod. The host should be able to communicate with pods, and if you meet these small set of requirements, then you should be able to get a working Kubernetes cluster. You may not get some of the more advanced features, but you should have something that works. And so we're starting with a very easy model, and then that actually gives the people who create SDNs the flexibility to really add a lot of value based upon the needs of the customer.
Yeah, the one use case that I think we have seen actually, one of the customers for Conti was SAP Ariba, was a public reference customer, was sort of a mixed mode use cases, right? You have VMs still, part of the application, and you want to have a application, not just defined container only application, but like a overall VM plus bare metal plus containers. For them, the containers can come up and go quickly, right? Kubernetes can bring it up, or somebody can bring up those quickly, but not the other ones. The VMs and the bare metals are sort of there. But if you want to connect them, all of them together, and the operator wants to have a holistic view of VMs plus, all of them part of a single application, and you want to have a policy that's end-to-end. Let's say I just containerize the front end, for example, for whatever reason, right? And then leave the rest of the stuff the way it is. I want to have a holistic application view. I think that's helpful. So one of the demos we have, not we have anymore, but one of the demos that Conti has in the booth is with the integration with our ACI, Cisco ACI, where there's a VM, HCD VM actually is a VM, and then a web tier and app tier in container format. And then the integration allows you to have an end-to-end view for contracts or policies. So that's a use case I've seen. Ariba, SAP Ariba is one of the customers. I think they spoke in a couple of forums. There's a few customers like that. So that would be the use case where you want the automation of the underlay to be as fast as the Kubernetes. So you don't want to have to manually do it after the fact or things like that. So you want to have automation. So that's why I would say SDN, to your point, we all worked in SDN companies before, so I don't know what SDN means. But if it means automation of physical switches, sure.
So is that maybe a better way of thinking of it, is that you have this abstraction now from the network layer, and you want to map that to, or from the Kubernetes network interface model, right? That's an abstraction model. And then underneath that, you can have an SDN, so you can have whatever advanced technology, controller-based networking model you need, if you need that in your environment. Is that maybe a better way of thinking about it?
Yeah, I think simply the existing technology of doing it manually doesn't work anymore, right? When you talk about containers, it is, people don't want to create a ticket to create a network configuration for you. I mean, so if you do have the other infrastructure and there's a lot of interactions with the existing infrastructure, I definitely see the value there. So for what it's worth.
Okay. All right. So.
By the way, we do see some of those hybrid use cases as well. I'll disagree that you need to have controller-based SDN under it, but yes, those use cases of VM and bare metal and Kubernetes is something we see as well.
I think it's not needed. I'm just saying it will be helpful to automate it, right? You need to be able to automate some. Well, yeah, you can sure automate. I'm just saying there's ways to automate it. Of course, all I'm saying is if SDN solution solves that problem, sure. But what I'm saying is there's a use case. That's all.
So I mean, again, to sort of try to corral that, in a sense, I think Christopher, you were even saying that, in a sense, the Kubernetes network is already a software-defined network component. If that's your interface into your application, then that can drive any automation it needs to drive, which might be, kicking off a bash script, even if it comes down to that level of control, right? So, yeah, okay. So I think we have a couple minutes left still. Do people have questions, or should I ask one more leading question, hopefully leading question? There are some questions in the audience. Yeah, I don't know if we have.
So I work for Comcast. There's a couple Comcasters in this room. One of our biggest challenges in the network architecture right now is migrating to IPv6. We have huge initiatives all across the board with IPv6. Would love to know more about IPv6 and Kubernetes and go into more detail with that.
I mean, I think if you look at it, we've said that Kubernetes is an IP per pod. There's really nothing in that says that's got to be IPv4 or IPv6. And I can't speak for any of the other solutions out there, but Calico is v6 native, has been from day one. That's fine. It's just another, it's IPv4 versus IPv6. The code paths are basically the same. I think the orchestration folks have been a little bit laggardly in doing that, mainly because a lot of people deploy these things on public cloud, and our public cloud vendors have not seen the light to deploy v6. You can't really get v6 on AWS or GCE or anything at this point. So until those platforms support v6, it's going to be hard. The orchestration, the Kubernetes group is, the Kubernetes folks are working on v6, but it's not there yet. I think most of the networking solutions will support it once the orchestrator gets around to supporting it.
Yep.
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 So okay. go push on the people that you have influence on to get v6 out there, because we're all waiting for it. It makes a bunch of things probably much easier for all of us.
The question was, who do you talk to? Yeah. Okay.
SIG Network and Tim Hawkins.
Okay. Okay. There was one more question here.
Tim's not going to like you for that.
So those of us that are used to traditional L2 isolation with VXLAN or whatever it might be from, let's just say it, an OpenStack world, I mean, when you have like host systems that are public facing and things like that, like, do you see there being an issue from a security perspective just using L3 versus L2? Like, I guess for me personally, I feel like there's this, it's easier to manage access and control and things like that using L2, where you have tunnels and that sort of thing, versus L3. Like, I appreciate the ease of debugging and deployment and everything of L3, but there's this like little thing in the back of my mind that's like, I feel like this is going to get hacked and it's going to be bad.
So let me ask you what the difference between the magic bits signifying an L2 label are, how they're any different from the magic bits that happen to be an IP address. Because at the end of the day, that filter for example, is being deployed on that host. If somebody's got root access on that host to undo the L3 filters, they most certainly have the ability then to reconfigure OVS to put you in a different L2 segment.
I think it's more about protecting myself from the internet, essentially, right? Where, like, if I'm doing L2, it's basically like one port. I don't have to have this massive wall or firewall set up on every node to basically protect. It's like, no, just like, I've got to have 4789 go from host A to host B. It's cool, if nothing else. But if I want to do that with L3, it seems like I kind of have to leave it open and trust.
So I think you get to what Brandon just said. These things have to fail closed. These have to be places where you grant permission. I want to open 443 from these things, not I want to block everything else. So you have to sort of think a fail closed versus fail open model. Anyone else?
I mean, I think that there should be choices, right? You know, I think not every customer or every scenario is going to be the same. I think the best way is to implement different options, and you choose based on that. So we have seen, for example, Conti, we implemented a sort of L2, native L3, and overlays, right? So these are all the way you connect things, right? Some people are, whatever. I don't want to, like argue with anybody, like, this is not the right way, or this is the way you should do it. You should have choices. I think there are choices, so I don't think you should worry about that. You have choices.
Yeah, and often before the packet hits the pod, it's usually gone through perhaps a firewall or through a load balancer or so on as well. So there you have a few options in terms of how you want to protect your application before those packets hit. That being said, one area that I think that we could probably spend a little bit of time focusing on is how do we segment the control plane from the data plane, and that I think would give us a real win, because even if they took over that particular pod, then that it doesn't make it impossible, but it's yet another step that has to be taken before you can compromise your control plane.
Okay, I guess think about that. It's still L3 packets that are exiting your pods. So the question is, in that model, do I want my pod to be ARPing across hundreds of thousands of other pods, or do I want it routed, something that's a little more scalable, much closer? That's an implementation detail, and that's not the way it's. Yeah. And you could do that with Kubernetes networking. I mean, that will work. It's just IP. The question is how you want to build that at scale.
Well, I was going to ask one more question, and that is, we've talked a lot about sort of networking in the state today. Is there any one key thing that you guys think needs to happen in networking in the near future to make it that much better for everybody? What's the next big thing, really, is kind of what I'm asking.
Yeah.
No? Nobody?
I think the biggest thing that is going on right now, I think, is the work in multi-tenancy that we've spoken about, and I think that multi-tenancy is going to open up a lot of use cases, both not just from like hosts, but also within enterprise environments, in order to help drive adoption of various applications. So I'm really excited about those efforts.
I think I was looking at the SIG, network SIG group. There's only like 2 open issues, basically. Maybe the next big idea is not there yet. So we need to add more. If you need some features, go ahead and submit an issue or something and work through the system. Other thing, I guess, would be network SLAs, monitoring piece. Maybe you can define policy to monitor a certain application or certain pod. I'm not sure. I'm not saying it's the next big thing. I'm just saying these are some of the things people have asked us to look at.
Sure. Okay.
I'd say work around kube proxy is one that I think we could make some improvements around adding additional functionality in kube proxy.
Yeah, I think my last one would be traffic shaping and like reservations and control. We have some hacks inside of Kubelet today, but I think we could do a lot better to make that like something you can slice and dice a little bit better.
Okay, great. Well, thanks everybody. Hopefully this was interesting and useful. I certainly enjoyed all the answers, and thanks to all the panelists for attending, and thanks to all of you for attending as well.